The equivalent resistance and the current out of a battery, 5 volts for a parallel circuit with 3 resistors, 2, 5, and 10 ohms. Prove Kirchhoff's current law by showing the current into a node equals the current out. I'm just going to throw this out. This problem is super complicated. It will not be that complicated on the final. It would be broken into parts. So this is an equivalent resistance problem and an Ohm's law problem and a Kirchhoff's law problem all at the same time. It would not be like that on the final. On the final, it would be an equivalent resistance problem and an Ohm's law problem separate and a Kirchhoff's thing separate. So it wouldn't be all like one big group. Okay. So number 20, find the equivalent resistance. So here is my resistor, 5 volts, connected to a resistor here. What is this one? 2 ohms. Connected to another resistor, 5 ohms. Connected to another resistor, 10 ohms. Okay, so equivalent resistance, if you look at your equations, there's 2 equivalent resistance equations. We got series and we got parallel. It says it's a parallel problem, so we use the parallel equation. It is possible that you have one that's parallel and series, in which case you have to break it into parts. But for this one that's just parallel or just series, you just use that equation. So it's 1 over R EQ, which is what we're solving for, equals 1 over 2 plus 1 over 5 plus 1 over 10. Okay, we need a common denominator to do this. My suggestion is 10. You could do lots of different ones, but 10 is the one that makes the most sense to me. So, yeah, this becomes 5 over 10, so multiply top and bottom by 5. This one becomes 2 over 10, multiplying the top and bottom by 2. And this one stays at 1 over 10. So when you add those all up together, you get 8 over 10. Remember, that's equal to 1 over R, and I don't want 1 over R, I want R. So you flip the top and the bottom. So you get 10 over 8, which simplifies to 5 over 4, or 1.25. Okay, so now we get into the crazy business. Why are you loitering in the hallway?
Well, I was kind of like, okay. Do we need to do test questions for this one?
No, in fact, I'm probably going to throw them out just because we're not going to have time to do corrections on them. So if we have time to do corrections next week, then I'll include them, but for right now, I'd say don't worry about it. Okay, so now we got to do Kirchhoff's law. So Kirchhoff's law says this. The current that leaves the battery, so the current coming in, has to equal the current going out. And the current going out is the current that goes through the resistors. So the setup would basically look like this. I battery equals I for resistor 1 plus I for resistor 2 plus I for resistor 3. And if you're wondering why I'm doing it that way, I'm looking at my equations, and here it is. Kirchhoff's current law, IN equals I out. So the in is the battery, the out is the resistors. So I just need to find all these values. So the battery is going to be, let's see, where am I going to do all these? I'm just going to do them over here. So the battery has a value of 5. It has a current of, don't worry about it, and it's got a resistance, of what I just found, 1.25 or 5 fourths. You would divide the resistance to the other side. When you did that, you would find the battery to be 4. The current coming from the battery to be 4. Okay, so that's the first one. I'm going to do the exact same thing for all of the other 3. So, they're in parallel. Things in parallel have the same... There we go. Voltage. Things in parallel have the same voltage. So if the voltage is 5, the voltage is 5 for everything. So for resistor 1, we would say V equals I1 times its resistance, which is 2. So I1 is 2.5. Okay, I2, voltage is still 5. I2, resistance for that one is 5. So I2 equals 1. Okay, V equals I3 times its resistance, which is 10. I3 equals 0.5. And oh look, the numbers work. Yay! So 0.5 plus 1 is 1.5, plus 2.5 is 4. Okay, as I mentioned, the problem would not be this bad on the test. What I would do is I would give you a problem like this, where you had to do equivalent resistance for parallel. And then I would give you a second problem where you would have to find the individual currents or voltages or resistances of the values. Okay? So you may have to use Kirchhoff's law. I may say something like the battery's current is 10, the current through the first one is 5, current through the second one is 2. Find the voltage of the third one. Well, you would do V equals IR because you know what I is, and you just go from there. Okay? So that's kind of something you could see, but like I said, it would be a little less complicated than that.